All right, guys, this video is going to kind of review scatter plots and what you should have learned yesterday. And I just want to make sure you understood how to do this. All right, so first thing, scatter plots. So obviously you know what a scatter plot is. It's a graph of bivariate data, which that basically means it consists of a pair of values. So two things. And it consists of ordered pairs on a coordinate plane. Scatter plots are used to help see patterns or trends in the data. So that's what they're used for. So if you're looking at these different types of graphs, hopefully you already have this, but if you need this in your notes, I'm just going to suggest to you guys anything you want to write down about scatter plots, put in your notebook. This first graph has a positive correlation. Okay, you should have saw that in your notes yesterday. As x increases, so as I go this way, the x is getting bigger, the y is also getting bigger. So that's a positive correlation. A negative correlation is as the x gets bigger, the y values are going down. Okay, so as x increases, y decreases. This is called a negative correlation. So again, as the x goes up, the y goes down. No correlation means there's no relationship. So x and y are not related to each other. There's no pattern. So whatever you're working with, these two things don't have any relationship to each other. So it might be like the month I was born in and how many pets I have. Those things do not have any relationship or correlation to each other. So that would be a scatter plot that would kind of look like this. So then the other thing that hopefully you got out of your math book yesterday when you were doing those examples is a line of best fit. So a line of best fit is a line that you draw through the points on a scatter plot that describes the trend of the data or shows how the two things relate to each other. Okay, so when we're making scatter plots or making lines of best fit, first thing you do is you're going to make a scatter plot of the data and then figure out is there any kind of relationship between the two things you're looking at. Then you're going to draw a line that closely follows the trend in the data. If you have a ruler, you're going to use that to make sure you draw a straight line, and it needs to go through about the middle of all of the points. Step 3, you're going to use 2 points on a line or near the line of fit to find the slope of the line and then make an equation for the line. And then the last thing, here's what we're going to use the equation for. We're going to use it for two things. One is called linear interpolation and one is called linear extrapolation. So linear extrapolation is the use of the data to predict values that are outside the range of data. So that would be like if it's not on my graph or I don't have it in the data, I'm going to use my equation to help me make some predictions. Linear interpolation is the use of linear equations to predict values that are inside of the range of data. All right, so now we're going to actually try a couple just to make sure you understand how to use lines of best fit. All right, so let's take a look at this scatter plot that we have. So if you guys look at this scatter plot, first thing hopefully that you notice is that as the years go up, oops, didn't mean to do that, as the years go up, it looks like the revenue from the car dealership is also going up. So this would show a positive correlation. Again, positive means as one goes up, so does the other one. So as the year increases, the revenue also increases. It says drawn a line that fits the trend. So now here's where all of our lines may be a little bit different, but you just need to draw the best line that you can of, and it's called a line of best fit or a trend line. So I'm going to try to draw a line that goes through the middle of most of the points so that there's about the same above and below. Again, it's not going to be perfect. I could not draw this with a ruler, but there's about the same amount of points above and below the line, and it tends to go through most of the points. So this would be my trend line or my line of best fit. Okay, so then it says, well, which of the 4 equations below seems to fit my line of best fit the best? And then how do you know? Okay, well, I can eliminate some of these right away. It says y equals negative 2x plus 2. Well, this one does not have a negative slope, so right away I can eliminate that one. Okay, what do you think about the other 3? Pause the video and pick which one you think maybe fits this best. All right, so to see what maybe fits this best, I'm going to find a couple nice points on my line. Here's one. This one crosses pretty nicely here, so I'll use this one. So it looks like it's counting by 2s. I'm going up 2, 4, and this way it's counting by 1. Over 1, 2, 3, 4, 5. So a good slope for me looks like 4/5. Y-intercept looks like it crosses about 2, so that maybe is another little hint. So I would say this equation fits it the best. But we're going to be working on actually writing an equation for a line of best fit. This is what you kind of did yesterday when I was gone. So now let's go through an example so I can make sure you know how to do it. All right, so now we are going to try one, a scatter plot, and we're going to try to write an equation for the line of best fit. So we have several groups volunteered to clean up litter along a mile of the highway near their town. The scatter plot shows how many people were in each group and how long it took to finish the job. So first thing I want you to do is just think about to yourself, what kind of correlation does the workers and the minutes, the time it took them to clean up, have with each other? All right, so this is a negative correlation. And here's why. Okay, you always start like this. As the, whatever the X value is, which is the workers, so as the number of workers goes up, what happens to the Y coordinate or the Y values? Well, they're going down. The time is going down. So the time it takes to pick up litter goes down. So that's called a negative correlation. All right, so that's kind of the first thing you should be able to do. Second thing is we want to try to write an equation for this line of best fit or this trend line. So here is how you do that. You don't just get to eyeball it and guess. Okay, so first thing you want to do is you want to find 2 points that you think you could use to find the equation of this line. So you're going to look at the line, find 2 points that are near the line or on the line. Okay, so this one is on the line. This one's also on the line. So I'm going to use those 2 points. Now, if you didn't have 2 nice ones like that, you might be like, oh, I'm going to use one that's super close, like this one, because it's pretty close. Okay, but I'm going to use 2 that are on there. So one of the coordinates looks like 15, 50. Okay, and then this one here, this one's a little harder. To me, it looks like about 9, 80. So I'm going to use that. So I'm going to use those 2 points. Okay, so we've been doing this the past couple days. So first thing you need to do to write an equation for a line is you're going to find the slope. So I'm going to do my Y coordinates and subtract them. 50 take away 80. And then my X coordinates, 15 take away 9. All right, so I'll give you a second to do that. All right, so 15 take away 9 is 6. 50 take away 80 is negative 30. If I simplify that, it equals negative 5. So there is my slope. Hopefully you notice that that matches up with your line. This is has a negative slope because it's going down. All right, now to write my equation of the line of best fit, I can use 2 different forms. I could use y equals mx plus b form, or I could use point slope form. I'm going to use y equals mx plus b because that's what most of you were using the past couple days. So I'm going to plug in my slope, negative 5. I'm also going to plug in an x and a y coordinate. I'm going to use 9 and 80. So instead of an x, I'll put a 9. Instead of a y, I'll put an 80. And I don't know my y-intercept. Again, you can't just eyeball that. Okay, so now I'm going to solve it. So I have 80 equals negative 45 plus b. If I want to get b by itself, I'll add 45 to both sides. And I end up with 125 equals b. So my equation for the line of best fit is y equals negative 5 and then x plus 125. There's my equation. So now if I wanted to try to make a prediction using this line, I could be like, so how long do you think it would take to clean up litter if I had 20 workers? So what I could do then is instead of an x, I could plug in a 20. Okay, and then I could solve it. I could say, okay, so negative 5 times 20 is negative 100 plus 125 is 25. So it would take me about 25 minutes if I had 20 workers. All right, your next steps now that you've watched that video is you're going to do a decimals activity. You may work on this with a partner if they are done with the video. So you need to wait till they are done with the video, or you can just start on your own. You can find that link in Schoology. And then if you still have time, this is not homework. Eventually it will be. So if you have any remaining time in class, there's a homework sheet in Schoology I also want you to try. Okay, and then we will wrap up things with scatter plots, or at least lesson 5.3 when I am back on Monday. So if you have any questions, save them for then.